Hello everyone, in this video we are going to discuss the problem Lunatic never content. So the problem states that we are given a array A of n non-negative integers and f of ax denotes A of 1 mod x, A of 2 mod x up to A of n mod x. So we have to find a biggest x such that this particular f of A of x should be a palindrome. So moving on to the solution. So suppose we are given the second array 3 0 1 2 3 0 1 2 0 3 2 1. Now for making a palindrome, this value should be equal to this value, that is 3 should be equal to that is after changing 3, and after changing 1 the value should be equal, right? So we can do x is equal to 1 because 1 mod anything is always 0. We can took n is equal to 2 because 3 mod 2 is 1 and 1 mod 2 is 2. Now we can't take x is equal to 3 because 3 mod 3 will give 0 and 1 mod 3 will be 1, which are not equal, right? So moving this particular observation, if we have two particular elements as 12 and 24, what our x can be? X can be equal to 1 2 3 4 6 12. What we are observing, only the factors of 12, all the numbers which are divisible by 12 and which are divisible by 12 24 are present as x, right? Similarly, if we are having 9 and 12, the value of x for which after taking mod we will get equal, it will be 1 3, it is 12. We can't take 4, we can have 6, no we can't have 6. We can have 9, no we can't have 9. Okay, so again if we take two numbers as 6 and 8, so we can have 1 which will divide both. We can have 2 and okay, only 2. So all this observation, what we are getting, the maximum value for which the both will be equal to the same number is absolute value of bi minus ai. You see here 24 minus 12 is 12, 12 minus 9 is 3, 6 minus 8, absolute value of 6 minus 8 is 2. So the maximum number after which if we take the mod will be absolute value of a of I minus b of I, where a of I this the starting number and b of I will be its corresponding ending value. So if we have all these numbers like 12 and 24 and here 6 and 9, so what our optimal x can be? One pair is 12 and 24. For this, the first pair 12 and 24, the value of x can vary from 1 2 3 4 6 and 12. And for the second number, that is for 6 to 9, 6 and 9, this pair, the x can vary as 1 2 3, 2 can't be there, 1 3 only. So now we are having 12 and 3. So if we take SCF of 12 and 3, we will get 3 because 3 is always present in this x. If we take another example as 6 9 and 4 and 8, in this particular condition, for pair of 6 and 9, the value of x can be 1 and 3 only, and for the pair of 4 and 8 the value of x can be 1, 2 and 4. So if we take SCF of 4 and 3, we will get 1. So only condition for this is to be optimal x equal to 1. If we take another example as 6, 8 and 6, 9, here for 6, 9 the x can be 1 or 3, and for 6, 8 the value of x can be 1, 2 only. Here also the x will be equal to 1, SCF of the largest number. We are finding this number just by finding all the values which are divisible by this and divisible by this also. So this was the algorithm. We have just find if this is our particular array. We have to make pair of first and last, find the absolute values of first and last. So this will be the value of maximum x for this particular, this will be x1 suppose. So this is the maximum value for this pair. X2 will be maximum value for this pair, and x3 will be maximum value of this pair. So after this we can take the SCF of all the numbers, which will give the maximum value, because the x should be satisfied for the all the pairs, right? So this is all about the solution. I will show you the code. I have also done the same in my code. I have taken the vector as input and created a temp vector. After for each pair I am pushing the absolute value of v of I minus v of I minus 1, that is its corresponding last element of the palindrome. After that I am finding the SCF of all the numbers and printing the SCF. Otherwise, if c is equal to 0, then that is all the numbers are 0, I will print 0, because in the condition if the size of temp is 0, then it will give a wrong answer. So this was all about the solution of this problem. Please subscribe to my channel for further videos. Thank you so much.